for the application layer, we actually are going to just summarize the applications that we have been talking about before. And this is in OSI, this is the 7th layer. But in TCP/IP, which was implemented in the internet, this is actually a combination of application, presentation, and session. And that's how we are going to talk about the 3 of them right here. Okay. And so we are going to explain the operations of application layer protocols and providing support to end users. Okay. So we'll look at the functions of the application, presentation, and session layers. We'll explain how end user applications operate in a peer-to-peer network. Then we look at web and email protocols. Expect us to talk about HTTP and HTTPS. We'll talk about SMTP, Simple Mail Transfer Protocol, POP, Post Office Protocol, and IMAP, the Internet Message Access Protocol. And then we look at DNS, the domain name service or system, and DHCP, the Dynamic Host Configuration Protocol. And then we look at FTP, and that's it. Yeah, that should take us less than 30 minutes, and we get out of here. So let's start by talking about the application layer. And the application layer, which is made up of always the first 3 layers of OSI, application, presentation, and session. They define the functions of the TCP/IP application layer. And all the applications that we always, get to talk to are always found here. So looking at my diagram here, you can look at all the applications found within the application layer and by extension, the presentation and session, whether it's HTTPS, whether it's SMTP, whether it's POP, whether it's DHCP, whether it's FTP, whether it's IMAP, all these are the applications that we find under them. And so today, let's now look at the presentation layer. What is the function of the presentation layer? Now, I'm sure we must have heard about some of these file extensions like .png. These are the portable network graphics. This is an image extension of pictures. We have the JPEG, Joint Photographic Expert Group. This is another photo extension or graphic extension. We have GIF, the graphic interchange. This is simulation pictures, and we use them on social media a lot. These are like animation pictures that you see there. We have things like the MKV, MPEG, the motion pictures expert group. These are for videos here. QuickTime is also here, And we have so many other file extensions. We've got file extensions like, we have .doc, we have .ppt, for PowerPoint. We have, .xl for Excel, so on and so forth. So the major function of the presentation layer, by the way, it has 3 major functions. It can help to present or format data so that it is formatted at the source in a manner that it can be compatibly received by the destination device. So formatting or presenting the data is the first function. Then it can also compress data at the source and decompress it at the destination. Okay, so compression at the source and decompressing at the destination. And finally, encryption at the source and decryption at the destination device. So these are actually functions, that should be performed by the presentation layer. And then, of course, we have the session layer. So in creating and maintaining dialogues between the source and destination, and I can give you a very good example. You've ever, you're browsing on your desktop computer or on your laptop, and then you leave it unattended or idle for some time. And when you come back, the computer has gone to sleep mode, and you have to either touch the keyboard or touch the mouse, and it's gonna wake up. And when it wakes up again, what happens is that you'd see the browser loading, to be able to load the previous page where you left it. And so that is the function of the session layer, because it's able to keep sessions alive or active. it can restart sessions that were disrupted or they were idle for a long period of time. That is the function of the session layer. All right. Now, the TCP/IP application layer protocols is always made possible by three protocols here. We have the DNS, which is the domain name system or service, which we saw as a port number 53, and it uses both TCP and UDP. And the major functions of DNS is translating the human domain, this human readable names into a particular IP address. And I can, of course, demonstrate that by using, I can query my DNS server manually. And so I just need this command, ns lookup. When I do ns lookup, and then I can now query my DNS server to tell me, I can ask it, Mr. DNS server, what's the IP address of facebook.com? All right. And the DNS server tells me, I can not only tell you the IPv4 address of the facebook.com server, I can also give you IPv6 address. All right. So you see, an address is beginning with 2, as we learned yesterday. This is a global unicast address, GUA. And it also has what? An IP version 4 address, public IP address. This is dual stock. This Facebook server uses both IPv4 and IPv6. And this is part and parcel of the transition process. I can ask it, Mr. DNS server, what is the IP address of google.com server? All right. And it tells me, I'm going to give you more than what you require. I'll give you both the IPv6 and IPv4 public IP right here. All right. And you can see that these are organizations, these are companies umeenda aje?
Guys, as always, ni mwalimu ni net yake imepotea, so amesema I'll be back shortly.
Okay. Can you hear me, guys? Someone, can you hear me?
Yes.
Oh, thank you, thank you, thank you very much. Thank you very much. Yeah, let's finish. We're just about to be done here, and then we can get going. And so, let me just share my screen again. Sorry for the interference there. Okay, so, yeah, so can you see my screen? Is it visible?
Yeah, sure.
All right,
Yes.
thank you. Yeah, so I was querying my DNS server, and I was asking my DNS server to tell me the IP addresses of the different, of the different servers that it knows. So I had queried google.com server, and I got both version 4 and version 6 of IP. I did google.com. I can still do, ku.ac.ke. This is Kenyatta University web service, and it's giving me a timeout somewhere there. I don't know why. It's giving me a timeout. Let me try, maybe, let me try youtube.com. youtube.com is the file server, and you can see youtube.com is giving me a timeout there. I don't know why. Oh, I know what I need to do. Can I just do ns lookup again and do facebook.com? It's there. So I can do now youtube.com, and you can see YouTube has both version 4 and version 6, and I can do maybe any I can do actually any, and I'll get the IP address of those particular servers. So that's the work of DNS. DNS translates the domain names into IP addresses, and you can also do IP back to the domain name. Of course, we also have DHCP, which is used for assignment or dynamic assignment of IP information or IP addresses. So DHCP uses UDP 68 and 67, and for IP address, it actually leases these IPs for a default time of 24 hours, but you can actually modify that timing. And then, of course, we have web server, which is used to set the rules for exchanging of text, graphics, sound, images, videos, and other multimedia files there. Okay, and so this happens over the World Wide Web, the www. So for it's actually a client and server-based protocol. For the client is the web browser, and the server is the web server there. Now, in terms of peer-to-peer communication, we have a PC1 here connected to a switch, and PC2 is connected to a printer and is still connected to the switch. This is normally within the same local area network. So if you have in your organization, in your department, if you have a PC2 connected to a printer, other PCs on the network can print on the same device, but they must always get permission through the PC2. And so this is an example of a peer-to-peer network. And we do have peer-to-peer applications. We do have peer-to-peer applications, like WhatsApp is a very good example of a peer-to-peer application. And we exchange messages over WhatsApp and over Telegram and all that. Those are peer-to-peer applications, and there are so many again. Now, looking at HTTP, let's look at how does HTTP work? And basically, we are going to check how do you manage to communicate with from your web browser, from the web browser to the web server. All right. So this is one of the things we're going to learn here. We're going to learn how is it that you're able to, I mean, what is the importance of the web browser within your networks? Okay. Now, normally a browser interprets three parts of a network. A browser interprets three parts of a network. It, let's say we have a web link like the HTTP :// www.cisco.com/index.html. So the index.html is the file we are actually looking for. So it is the work of the browser to interpret those three parts. First is the protocol, the HTTP part, or it could be HTTPS, that is actually what's called the protocol, or the scheme. Then the browser has to interpret uh, the www.cisco.com. This is the server name. This is the name of our server, which can be converted into an IP address, remember, by DNS. And then the index.html, this is the specific file that we're actually browsing for. Now, it's important to note that the second step of this process is very significant, because on the second step, once the browser has interpreted the three parts of the URL, then the browser is going to check with the name server. And which is the name server? This is the DNS server. The name server is the DNS server. So the DNS server will convert this cisco.com name here into a particular IP address. Okay. And the IP address is actually needed. Why is it needed? The IP address is needed because we need to use it to connect to the server. You want to connect to the web server. So the DNS will translate the name, this name, into a particular IP address, and the browser will now use that IP address to now connect to the server, because the devices normally communicate using IP addresses. The devices must always communicate using IP addresses. That is important to note. A device without an IP address, because the IP is the internet protocol, and any device participating within the internet protocol must have an internet protocol address. Then once the IP address is known and the device has established connection to the server, web server now, the client will initiate now an HTTP request, okay, by sending a GET message or a GET request to the server to ask for the web pages, a web page called index.html. Then finally, not really finally, the second last thing is that once the request is sent, a response will be sent from the server. A response will be sent from the server back to the client. The only problem is that the response will always be an HTML code, from the web server. We are not, I mean, only programmers will understand this. The normal human being, you might have a hard time interpreting this, but you need your browser to interpret this. And that is where the web browser comes to handy. You need your browser to interpret that particular HTML code. The browser will decipher or interpret that HTML code into a format that, is shown in this window, something we are able to understand, like your time is now, or how to log into the web server of netaka.com or Cisco or something like that. So it is the work of the web browser to interpret now the HTML code into a format that we're able to read as humans, right? And that is exactly how HTTP behaves with the browser, with the web server. So we do have two formats of HTTP. We have the HTTP and the HTTPS, and the one with the S is the secure one, and it uses two protocols, SSL and TLS. SSL is secure socket layer, and TLS is transport layer security. Okay. Now, HTTP is basically, this is a request and response protocol, which is normally specifying message types. And the three major types of messages is GET, which is used by a device, request for information from the web server. So the web browser sends a GET message to the web server to get some web pages or HTML pages. Now, to upload data files, like some data uh, in table format, or to write some paragraphs of words or stories within the website, we use the post command. And to upload things like images, videos, uh, audio files, we use the put method. So the get, post, and put are three different messages that the web browser communicates with the web server. All right. Of course, we have talked about email protocols, and we have three protocols of email. We have SMTP, which is Simple Mail Transfer Protocol, which is used to exclusively send emails, just sending emails. Then we have the remaining two is the POP, which is Post Office Protocol, and IMAP is Internet Message Access Protocol. Now, just from the word Post Office Protocol, when you want to pick a parcel or a letter from the post office, if you ever lose that letter, you cannot go back to the post office and tell them that, did you have a copy of my parcel here? Because I lost the first copy you gave me. So these guys, they never have a copy of your parcel. The same thing with post office protocol. The post office protocol, when someone sends you an email message, it's actually deleted from the mail server. So in the next 2 months, 3 months, 2 years, 5 years, you can never refer back to the same email. Unlike IMAP, and the two of them, by the way, are used for receiving emails. IMAP, you can receive an email today, you read it. Tomorrow, you can refer to the same email. Next week, you can still refer to the same email. And in 5 years to come, you can still refer back to the same email. So those are the three email protocols that we have. The last two are for receiving, but IMAP is also used for retrieving an email that has been read before. In terms of IP addresses, we have already talked about DNS, and DNS is used to translate domain names, and we have domain names that begin with .com for businesses and the industry, .org for non-profit organizations, .au for Australia, .us for United States, the ZA should be for South Africa, .adu I think should be for educational institutions, .sc.ke is for academic institutions, so on and so forth. Those are just different hierarchies. I already talked to you about NS lookup, and we did manually query the DNS server to give us the IP address of specific IP addresses. All right. DHCP, Dynamic Host Configuration Protocol. We have been talking about it. And this is a protocol that is used to automate the process of IP assignment or leasing. And the addresses that are always leased include the IP address itself, subnet masks, default gateways, DNS servers, domain names, so on and so forth. And so if you consider your network is a big network, and even if it's a small network, you want to consider obtaining IP addresses automatically. But you can also consider to assign IP addresses statically, which means you do it manually, though that comes with its own confusions, all right? But nowadays, many networks use both static and dynamic because they are specific devices which only work well under static, because these are devices you want to access them remotely and don't want their IP addresses to change, because it is the address with which you use to access that device remotely. All right. So DHCP, of course, we have version 4 for provision or leasing of IPv4 addresses, and we have DHCP-v6 for leasing of IPv6 addresses. And we did talk about that yesterday, and we'll have a whole chapter for DHCP for version 4 and version 6, and that will, I think, come in the next module, CCNA 2. All right. Now, DHCP, like I told you, from the moment your computer is powered on, from the moment the computer is powered on, let's say this is my computer, we call it a DHCP client because it needs to communicate to a DHCP server. So the moment your computer is powered on, the first device it needs to communicate to is a DHCP server, and it sends a broadcast message to any device that is a DHCP server in the network. And so 4 messages that are used by your PC or laptop or mobile phone to communicate with the DHCP server available in the network in order to acquire IP information. Now, the messages are as follows. The first message is called DHCP discover message, which is used by the PC to discover any DHCP servers in the network, sent as a broadcast. The first DHCP server to receive that DHCP discover message will respond back with a DHCP offer message. And the offer will carry all the information that is needed, including the IP address, subnet mask, default gateway, DNS, domain name, so on and so forth. Once the P client receives the offer, it cannot use the offer immediately. It must send another message called the DHCP request, which is basically requesting to use this offer. All right. So DHCP request will request to use this offer to the server, and then the server will respond back with the final message called DHCP ACK, which is acknowledgement. All right. And so I'm trying to form a mnemonym here. I'm trying to form a mnemonym with the word discover, offer, request, and acknowledge. And I just came up with a word called DORA. DORA is the mnemonym for mastering the 4 messages transmitted with DHCP. Okay, DORA is the mnemonym for discover, offer, request, and acknowledge. These are the 4 messages. Once this is complete, these 4 messages, then the PC will actually, take that offer and use it for a default time of 24 hours, but that time can always be modified. Now, that is for IPv4. We do have the same messages in IPv6. The only thing is that they have different names, all right? So when you talk about DHCP discover in IPv6, it is called solicit, all right? When you talk about DHCP offer, the IPv6, it is called advertise, all right? When we talk about a DHCP request, we talk about information request or just the word request, all right? And when you talk about DHCP acknowledgement, in IPv6, it is called reply. In IPv6, it is called reply. In IPv6, it is called reply. So that is how DHCP operates for any mobile phone, any desktop computer, any of them actually uses those ones. Let's talk about the last thing to bring this to a close, and we talk about file sharing services. And in file sharing services, basically we are talking about FTP, which is the file transfer protocol. This is a protocol which allows transfers between clients and a server. So you have an FTP client, which will be a PC or your mobile phone, and FTP server is where you download from. So we do have 2 words here, which have been given new names. We have the push and pull names, where the push is used to describe the process of uploading, and the pull is used to describe the process of downloading. All right. And so, because FTP works under TCP, FTP uses 2 port numbers, and we did see them. We have port 20 and port 21, where port 21 is used for session establishment. We talked about the TCP through a handshake. So to establish the first connection to the server for control traffic, 21. Then port 22 is now used for the actual data transfer, data transfer port 20. And thereafter, data transfer will happen. And there'll be a lot of downloading and uploading, pulling and pushing, so on and so forth. So that is FTP for us. And I think right now is a very good time for us to end this and to bring this to a close. All right. So next week we will actually be we just have